might give you an indication about what's to come based off of what we've learned already. Moles are definitely involved in this concentration calculation. So as I mentioned, molar concentration takes into account, again, we're still comparing the amount of solute versus solution, but in this case, the amount of solute is measured in moles and the volume of solution is measured in liters. So you have a value that's going to be moles per liter. So a lot of times what you might see is if something has a concentration of, let's say, 1.5 moles per liter, right? So that is one way of expressing this concentration. Or you can also see this written as 1.5 big M, right? This is communicating the same thing. 1.5, this big M tells me moles per liter. So these are communicating the same value. Now, we also have to keep in mind that when we're doing calculations, and if we're using this as a conversion factor, remember that we can write, depending on the situation, 1.5 moles per liter, or we can write 1 liter over 1.5 mole. Now that's just to give you an indication about what's to come, because in case we have to cancel out moles or cancel out liters, you might want to write one version of this number over the other. Now those are not the same. Remember when we did dimensional analysis, writing this way just allows you to cancel out the units and get to the unit that you require. Okay, so when you're talking about molar concentration, you're referring to a concentration that's moles per liter. Moles of the solute divided by liter of solution. And if you see this big M, that just means moles per liter, right? So let's actually get into an example. So it says, determine the molar concentration of the following solution. This solution contains 4.35 moles of potassium manganate, are dissolved in enough water to give 750 milliliter of solution. Now the phrasing is a little bit weird, but we are given the moles of the solute and the volume of the solution as well. So with both of these numbers, we should pretty easily be able to find the concentration of this solution. So as we mentioned, so concentration, I'm going to put this as a C, is equal to 4.35 moles of potassium manganate divided by, we need the volume in liters. And since I have this in milliliters, this divided by 1,000, so let me just show you the work here. I won't be doing this for all of the conversions from milliliters to liters, but just in case this helps. So for every 1 liter, there are 1,000 milliliters. So if I wanted to convert to liters, I would have to divide by 1,000, which gives me 0.750 liters of the solution. So 0.750 liters. So I've got moles divided by liters. So my concentration is 4.35 divided by 0.750, which gives me 5.80 moles per liter. Or, as I showed you earlier, you can write this as 5.80 big M. Okay, so that's how you do that first question there. Let's keep going and let's see different variations, different questions that you might be asked with regards to concentration. All right, example 2. Sodium carbonate is a water softener that is a significant part of detergent used in a washing machine. A student dissolves 5.00 grams of solid sodium carbonate to make 250 milliliters of solution to study the properties of this component of detergent. What is the molar concentration of solution? Now, let's start off with the numbers that we're given. So we're given the mass of this particular compound and we're given the volume. Remember, when we're trying to find concentration, you want moles per liter. So milliliters to liters, that's a pretty straightforward calculation. But how do we go from grams to mole? Now that makes us think about all the things we learned about the mole previously, right? How do we go from grams to mole? And of course, we have to use the molar mass. So let's first figure out what compound we're talking about here. Sodium carbonate, Na2CO3. So if we start off with 5.00 grams of sodium carbonate, and I want to get to the moles of sodium carbonate, I have to find the molar mass. So in 1 mole of sodium carbonate, how many grams are there? And we can find this value by looking at the periodic table. And the periodic table tells us, give me 1 second, sodium has a molar mass of 22.99. And because there's 2 sodiums, I'm going to multiply this by 2, plus carbon has a molar mass of 12.01. Of course, all of these are grams per mole. There's 1 carbon there, so I'm good. 16.00 grams per mole of oxygen. And because there's 3 oxygens, I'm going to multiply by that by 3. So I'm going to get 22.99 times 2 plus 12.01 plus 16 times 3, which will give me 105.99 grams per mole. And that's what I'm going to put down here, 105.99 grams for every 1 mole of sodium carbonate. So basically, this allows me to make that conversion to moles of sodium carbonate. Now, I've got moles of sodium carbonate, but I want to get to moles per liter of sodium carbonate. How do I do that? So my grams part, that's pretty much done. My moles will end up at the top, but how do I get liters on the bottom? Essentially, I just have to convert and put the liters down here. So 250 milliliters is 0.250 liters. And then I can just put the numerator of 1 here. Why do I put 1? The unit that I want to end up as the numerator at the end is moles. And I've already gotten to that point, right? So there's no other unit that is desired in the numerator that I would put here. So I can just leave this as a 1. So if I check, moles is the unit that I'll end up with in the numerator, and liters is the unit that's going to end up as the denominator. That kind of checks out. Let me just do this calculation. So I have 5.00 divided by 105.99 divided by, again, 0.250, which is going to give me 0.18869. There are 2 significant digits in the question, which means that's how many significant digits there are going to be in my answer, 0.19 moles per liter. So let me just recap what I did there. So I took a look at what was given to me in the question. I was given the mass, which I used the molar mass to convert to moles. Once I got the moles, I divided by the volume in liters so that I can end up with moles per liter. This is my concentration of this particular solution. There is a part B to this question, which we can use the numbers from part A as well. So it's asking us, what is the concentration of only sodium ions in this solution? Let's go back to our formula. It was Na2CO3. So if you're talking about sodium ions, say this breaks apart, and I have Na plus CO3 2 minus. When this breaks apart, for every 1 mole of Na2CO3 that's there are going to be 2 moles of Na plus, right? So the ratio between this compound and this ion is for every 1 sodium carbonate, there are 2 sodium ions. So let's start off with the concentration that we found earlier, 0.19 moles per liter of Na2CO3. right? So my moles here, I want in the end it to be moles of Na plus over liter. Moles per liter is my concentration. So 0.19 moles of Na2CO3 for every 1 liter. I want to try and find the concentration of moles of Na plus. How do I do that? Let's try and cancel out our units. So I've got moles of Na2CO3 for every 1 mole of Na2CO3. There are 2 moles of Na plus. Right? So this allows me to cancel out moles of Na2CO3. So if I do 0.19 times 2, that gives me 0.38. That's how many moles there are in 1 liter of solution. That's how many moles of Na plus there are. So the concentration of Na plus is 0.38 moles per liter, or remember what we said, 0.38 big M. All right, let's try one more example. So sodium hydroxide is the main ingredient in many cleaners. Suppose 125 milliliters of drain cleaning solution is prepared by dissolving 8.2 grams of sodium hydroxide in water. What is the molar concentration of solution? So I'm already given the volume here. Pretty happy about that. So I'm given the milliliters, but I want to convert it to liters. So I know divided by 1,000, it is 0.125 liters. Okay, and I'm given the grams of sodium hydroxide, but remember they're asking for concentration, which is moles per liter. I've got the liters part pretty much checked out. I just need to convert this grams into moles. So let's do that. 8.2 grams of NaOH. And I need to convert to moles of NaOH. So how do I go from grams of NaOH to moles of NaOH? And that has to do with the molar mass. So for every 1 mole of NaOH, how many grams of NaOH are there? So I'm gonna maybe change colors here just to make things a little bit more easier to understand. Sodium has a molar mass of 22.99 plus oxygen has a molar mass of 16.00 plus hydrogen has a molar mass of 1.01. Again, all of these are grams per mole. Grams per mole. So if I add all of these up together, 22.99 plus 16.00 plus 1.01 will give me a molar mass of exactly 40.00 grams per mole. So for every 1 mole of NaOH, there are 40 grams of NaOH. So now I've converted, so my grams of NaOH gets canceled out. I've got moles of NaOH. Now, in order to account for the liters, all I have to do is divide by 0.125 liters. And then I'm going to put the number 1 at the top. So this is so that I can end up with moles per liter of NaOH. Okay, so let's actually do the math. So 8.2 divided by 40 divided by 0.125 will give me 1.64, which means my concentration is 1.6 moles per liter of NaOH. Lastly, there's one more problem. How many liters of a 0.0020 moles per liter sodium dichromate solution contains 5 moles of sodium dichromate? So in this case, you're given the concentration and you're given the moles, but you have to find the volume. So you want to end up with your answer in liters. So something liters, that's got to be your answer. Let's take a look at the concentration. So I've got 0.0020 moles per liter of sodium dichromate. So Na2Cr2O7. And I need to somehow get this so that my answer is in liters. So maybe I can start with the moles written out, right? So I want to show that my moles will cancel out. So if I start off by writing, let's here, 5.0 moles of Na2Cr2O7, what can I write here, or how can I express the concentration so that my moles cancel out and I end up with liters? So you would have to write the value of moles of Na2Cr2O7 at the bottom and liters at the top. And for concentration, I have 0.0020 moles of Na2Cr2O7 for every 1 liter. So writing it this way allows me to cancel out the value of moles and end up with just liters. So if I do my calculation, 5.0 divided by 0.002 will give me 2,500. That is the volume. 2,500 is the liters of this particular solution. Okay, that's pretty much it.